Hello, good morning, class. So, yes, we were discussing the class 9 physical science, the first chapter, which is measurement. All right. So, in measurement, when we were talking about measurement, we have already finished two previous classes. Okay. For that, you have already seen the videos and also the notes which I've provided. So, from that, I think so you must have already understood most of the topics. Okay, so what today's class is going to be is about today we are going to discuss more questions and answers so that we will be able to answer the questions that is asked from the chapter. All right. Yes. So like I said, today we are going to discuss the questions and answers. Okay. So let us discuss the first question. What is a unit? And explain the importance of a unit in measurement and what are the fundamental and derived units. Okay, so the question is divided into three parts. The first part says what is unit. Second is explain the importance of unit in measurement. Okay, so we need to tell what how is it important to us. Okay, in measurement. And the third part is what are fundamental units and what are derived units. So now let us answer the questions. So the first question is what is a unit? So the definition would be a unit of measurement is defined as a definite magnitude of a quantity defined and adopted by convention or by law that is used as a standard for measurement of same kind of quantity. Okay, so this is actually a definition that is given for the unit. Okay, now to understand what is a unit, a unit it is a standard quantity. Okay, we have already understood what is physical quantity. Physical quantities are quantities which can be measured. Okay, so now there is an unknown quantity, we need to measure it, and to represent that we need a unit. All right, so त्यो युनिट हामीलाई चाहिएकोले गर्दाखेरि चाहिँ त्यो युनिट चाहिँ के अरे भन्दाखेरि चाहिँ त्यो सेम फिजिकल क्वान्टिटी. अब सपोज इफ वी आर मेजरिङ अ लेन्थ होइन, त्यो लेन्थको मेजर गर्नको लागि त हामीलाई मिटर सेन्टिमिटर चाहियो नि त. सो सेम खालके फिजिकल क्वान्टिटी बट विथ विच हेज अ स्ट्यान्डर्ड. ओके, सो स्ट्यान्डर्ड विच इज नोन अलरेडी. सो त्यो एउटा स्ट्यान्डर्ड जुन चाहिँ नोन छ त्यसलाई चाहिँ युनिट भन्छ. सो द्याट वी आर गोइङ टु युज एन्ड फाइन्ड अल अननोन quantity and then measure. All right, so that is the first part. Next thing is explain the importance of unit in measurement. So अब हामीलाई युनिट चाहिँ किन चाहिँ मेजर गर्दाखेरि चाहिँ किन युनिट चाहिँ इम्पोर्टेन्ट हुन्छ भनेर गर्दाखेरि चाहिँ के गर्नुपर्छ भने चाहिँ देयर आर थ्री इम्पोर्टेन्स. ओके, the first one is many of the measurement are easier to calculate. Okay, so what happens if the units are in the suppose if we are measuring, suppose let's say um, weight. Okay, suppose if we are measuring weight or a mass of something, it will be in kgs and it will be in grams. Okay, so that way it will be easier for us to calculate. Now nobody will give us a weight of something, okay, or a mass of something in kilo or this thing, meters or centimeters or even seconds. For that you obviously will require kg, gram, and all and such kind of things, which is the unit for mass. Okay, the next thing is better accuracy for what is being measured. Okay, so you will have a better accuracy at that. Third part is magnitude of the measurement is more understandable. Okay, so what happens when we have a unit next to it, so that time the magnitude of it will be understandable. Suppose if I tell you that the length of the length of a pencil is 2. Okay, so I just give you the magnitude. So 2, the magnitude which I'm telling 2 होइन. अब मैले भनेर एउटा पेन्सिल छ अरे, पेन्सिलको लेन्थ चाहिँ 2 भनेर. So 2 त के भयो, 2 त just it's a magnitude. There has to be some units to define it. Alright, so 2 चाहिँ के हो, 2 सेन्टिमिटर हो कि 2 मिटर हो कि 2 किलोमिटर हो कि के हो भनेर. Okay, so I have to define saying that I have a pencil which is of 2 centimeter. Okay, त्यो भन्नुको चाहिँ 2 सेन्टिमिटरको एउटा पेन्सिल छ भनेको जस्तै हो. Next, what are fundamental units and what are derived units. Okay, so fundamental units are units which are used to measure the fundamental quantities. Okay, example of fundamental units are meters, kilograms, ampere, etc. In the previous video and the first lecture, I have given you a table which has all the fundamental units and also the symbols which represent that. The next thing is we need to understand is what are derived units. Okay, so the units which are derived from the fundamental units are actually called as derived units. Okay, so derived units, okay, they are actually units, but from where do we get it? We get it from the fundamental units. Okay, so the units which are derived from the fundamental units or the basic units are called as derived units. The example is cubic meters, kilograms per cubic meters. So all these kind of things are examples of derived units. All right. So with this, we have finished the first question. Now let's go to next question. So the next question says, what are the different type systems of units? Okay. So there are many systems of units. Okay, but for us, which is important to us and which we will be using in the future also. Okay, we'll be dealing with it. Is there are three systems of units which are more important to us. There are actually many more. There are almost five to six. Okay, but the most important ones are three. They are SI unit, MKS units, and CGS units. Okay, so these three kinds of units are important to us. The first one, SI unit, is the standard international system of units. Okay, the next one is MKS units. MKS stands for M stands for meter, K stands for kilogram, and S stands for second. Okay, so it's meter, kilogram, and second. The next one is CGS units. CGS units stands for centimeter, gram, and second. Okay, so CGS units are the smaller units and MKS units are the larger ones. So we have three types of system of units. The next question is, what are the advantages of uh, SI system over the CGS system? Okay, so we just discussed that there are three different types of system of units. One is the SI, MKS, and CGS. Now they are saying what are the advantages of SI system over the CGS system. So the answer is SI unit is same everywhere. Okay, so the value of SI unit it is adopted internationally. So internationally मतलब जहाँ पनि तिमीहरूले गएर SI unit चाहिँ जुनै चिजको पनि एउटा केही चिजको एउटा physical quantity को if you want to have the SI unit of it, it is fixed everywhere and it does not change anywhere. जुनै ठाउँमा गयो भने पनि. But whereas the CGS system may vary from place to place. Okay, so the CGS unit may be different. Okay, but the SI system is the same everywhere. So that is why it is more advantageous over the CGS system. Next question. Describe how a mass of a body is measured. Okay, and what is the unit of mass? Now we need to understand how a mass of a body is measured. Now we were discussing and we were telling that there are physical quantities and the physical quantities are mass, length, time, current, all those kind of things. But now we need to know how to measure mass of a body. Okay, so the mass is a quantity of matter contained in a body. Okay, so now what is mass? First, before knowing how to measure a mass of a body, we should understand what is mass. So mass is the quantity of matter which is contained in a body. Okay, and you people might be confused with mass and weight. Mass and weight are not same things. Okay, because the unit of mass, when you see the unit of mass is kg or gram or milligram, so it goes that way. That is the unit of mass. But whereas when we talk about weight, weight is a kind of force. Okay, what is the weight? It is actually the force which is exerted by the gravity on the mass. Okay, that is why when we find a value for weight, we do it as weight is equals to mass times the gravitational acceleration. Weight force is equals to m into g, where g is the gravitational acceleration and m is the mass. So that is why the unit of weight is Newton, but the unit of mass is kg. Okay, so now keeping that aside, अब त्यो कुरा होइन अहिले, अब हामीले चाहिँ के बुझ्नु पर्यो भने चाहिँ एउटा मासलाई चाहिँ body होइन, a body has certain mass. Now how should we measure it? So त्यो चाहिँ कसरी गर्छ भने चाहिँ the mass of an object is measured by a beam balance. Okay, now what is a beam balance भन्दा चाहिँ a beam balance consists of two pans. So there are two pans. Okay, the object whose weight is to be measured is kept in one pan, and the standard object should be kept in the other pan until the pans are balanced. Okay, so the photo of a beam balance is out here. Okay, so your beam balance चाहिँ के हो एक्चुअली तराजु होइन, यसमा हामीले जाँदाखेरि काहीँ ठाउँमा जाँदाखेरि यसमा एकपट्टि हामीलाई अब केही चिजको वेट चाहिएको छ अरे होइन, सपोज इफ आई हेभ फ्यु एप्पल्स विथ मी, मेरोमा एउटा कतिवटा एप्पल छ अरे, मैले 1 केजी एप्पल भनेर खोजेँ, त्यो के गर्छु म एक साइडपट्टि तराजुको एक साइडपट्टि 1 केजी एप्पल राख्छु, अर्को साइडपट्टि 1 केजीको वेट राख्छु नि त। अन्त जबसम्म त्यो दुईटा ब्यालेन्स हुँदैन त्यति बेलासम्म हेरेर जब ब्यालेन्स हुन्छ आई नो द्याट द्याट क्वान्टिटी अफ एप्पल इज 1 केजी होइन, सो त्यति क्वान्टिटी चाहिँ हाम्रो 1 केजी हो भनेर थाहा पाउँछ। सो द्याट इज एक्चुअली द कन्सेप्ट अफ अ बीम ब्यालेन्स। सो मास चाहिँ कसरी गर्छ भने मास इज measured using a beam balance, and what is the unit of mass? The unit of mass is kilogram or kg. The next question is describe a pendulum clock and a stopwatch. Okay, so now there are two kinds of things. One is a pendulum clock and another one is a stopwatch. So now we should describe each of them. So a pendulum clock is a clock that uses a pendulum. And what is a pendulum? It is a swinging weight as its timekeeping element. Okay, so the timekeeping element चाहिँ त्यसको लागि चाहिँ pendulum clock को लागि चाहिँ के हुन्छ अरे, it is a swinging weight. Okay, I'll show you a picture of it, you know, which will make you more clear. So this is a pendulum clock. यस्तो खाले घडी देखेको तिमीले? There will be a kind of a clock out here, and there will be a weight which is hanged below it, and the weight keeps swaying from left to right, you know, left to right, the left hand side, the right hand. So that is actually the swinging of the weight is actually the timekeeping element. त्यसले नै चाहिँ हाम्रो टाइम क्याल्कुलेट गरेर चाहिँ हाम्रो क्लकमा देखाउँछ. Okay, so the pendulum clock, it's a pendulum. A pendulum clock is a clock that uses a pendulum, that is a swinging weight, as its timekeeping element. Now next, talking about a stopwatch. A stopwatch is a watch with buttons होइन, अब त्यो चाहिँ के हुन्छ अरे चाहिँ स्टप वाचमा चाहिँ के हुन्छ अरे बटन्स हुन्छ which you press at the beginning and at the end of an event so that you can measure exactly how long it takes होइन. सो एट स्टार्टिङ र एन्डमा चाहिँ हामीले त्यो टक टक त्यो बटन थिच्छ, त्यो थिच्दाखेरि चाहिँ के हुन्छ भने चाहिँ we will exactly know and we can measure exactly how long that certain event has taken place. Okay, so it is actually used for timing events such as स्पोर्ट्सहरूतिर. अब कसैले रेसहरू गर्दाखेरि चाहिँ त्यो स्टप वाच चलाउँछ नि, अब फ्रम द स्टार्टिङ द्याट पर्सन जस्ट प्रेसेस द बटन अफ द स्टप वाच होइन, कुद्दै गयो त्यो एन्ड उता लाइनमा फिनिसिङ लाइनमा पुग्ने बेलामा फेरि टक्क स्टप वाच थिचेपछि वी विल कम टु नो द्याट ही हेज फिनिस्ड द रेस इन दिस मच टाइम भनेर होइन. सो त्यो चाहिँ स्टप वाचको काम. So the stopwatches are also two types. One is this analog stopwatch and this is a digital. यो चाहिँ अहिले स्पोर्ट्स पर्सनहरूले पुरा चलाउँछ यस्तो digital stopwatch. So these are the pendulum clock and the stopwatch. Okay, so there are the pictures. Next one is, do all derived units need more than one fundamental unit? Okay, so there is a question. के भन्दैछ भने चाहिँ सबै derived unitsहरूलाई चाहिँ के भन्छ, do all the derived units need more than one fundamental unit भन्दैछ होइन. antati ke bhanechha to explain with examples bhanechha. The answer to this is yes, all the derived units need more than one fundamental unit. Because if it just has one fundamental unit, then it is as good as saying that it is a fundamental unit. The derived unit हुनु सक्दैन. Okay, for it to become a derived unit, it has to have one or it has to have two or more than two fundamental units added to it. Okay, so example could be a very simple example, the formula for speed. You know, to calculate the speed of anything, हो तिमीहरूले सानो क्लासमा पढेको होला स्पिड खोज्दाखेरि के गर्छ स्पिड इज इक्वल्स टु डिस्टेन्स बाई टाइम होइन सो नाउ वी निड टु नो द युनिट अफ स्पिड वी नो द युनिट अफ डिस्टेन्स होइन डिस्टेन्स मेजर गर्दा केमा गर्छ मिटरमा गर्छ सो द्याट इज द युनिट अफ डिस्टेन्स इट इज अ फन्डामेन्टल क्वान्टिटी नेक्स्ट टाइम होइन सो टाइम गर्दाखेरि के गर्छ टाइम इज अल्सो physical property, okay, and it comes under the fundamental units. So time co units seconds, okay. So we have distance and we have time, and the speed is equals to distance by time. So therefore the unit of speed will be meters per second, okay. So meters is the length of unit of length, and second is the unit of time. So therefore, hence using the meter and time as two separate fundamental units, it combines and it becomes a derived unit for speed, which is meters per second. Clear? Describe an ordinary scale. How could the length of a straight line be measured with it? And what is a parallax error? Okay, so there are three questions again divided. The first question says describe an ordinary scale. Okay, so an ordinary scale can be defined as a tool or a device used to measure the length and draw straight lines. Okay, so it is it is defined as a tool or a device which we can use to measure the length, or it can be used to draw straight lines. And a scale ruler scale. So that is an ordinary scale. And how could the length of a straight line be measured with it? So we could measure the length of the straight line by putting it on a line segment. Okay, so if we have a line AB, एउटा कुनै line छ अरे AB, त्यो line segment को चाहिँ हामीलाई length खोज्नु भनेको छ. त्यो चाहिँ कसरी खोज्छ एउटा त्यो straight line को भन्दा चाहिँ we could measure the length of a straight line by putting it on the line segment and reading the markings. अब त्यो ruler मा marking हुन्छ नि त. But we should remember that the starting point should be at 0 and the ending point of the marking will give us the answer. So this is the your photo. The red line is a straight line, and to measure the length of that, we keep the ruler on top of it, and we see that the starting point is kept at 0 on the in this case it is almost 3.2 centimeters. Okay, so 3.2 centimeters will be the length of that straight line. Next, what is a parallax error? A parallax error when the measurement of an object's length is more or less than the true length because of your eye being positioned at an angle to the measurement's marking is called a parallax error. Okay, so you have a scale, okay, and you have a length. एउटा point छ अरे त्यहाँनिर हामीले mark गर्दैछौँ. When you are at the when your eyesight is perpendicular to the plane of the paper, okay, or when your eyesight is perpendicular at 90 degrees to the plane where the point is there, that time you will have the correct reading. Okay, but if you are at an angle, okay, that time you might miss the point and then you might see a different reading. So that is actually a parallax error. When your eyesight is when your eyesight is at an angle, okay, more than that of the 90 degrees. Next, let us see the next question. What is a measuring cylinder and how can you measure the volume of a stone with the help of it? Okay, so first thing we should define what is a measuring cylinder, and then we should tell how can we use a measuring cylinder to find the volume of a stone. Okay, so a measuring cylinders. Okay, measuring cylinder पछि there are different kinds of names to that. A measuring cylinder पनि भन्छ, graduated cylinder पनि भन्छ, because there are gradings हैन, त्यसमा reading हुन्छ नि त. So there are, it is also known as graduated cylinders or mixing cylinders. Okay, so a measuring cylinder or graduated cylinder or mixing cylinder is a piece of laboratory apparatus used to measure the volume of liquids, chemicals or solutions. Okay, so chemistry ल्याबहरुतिर हुँदाखेरि अझैमा पनि तिमीहरूले यस्तो त्यो पहिलातिर अब इफ इभन इफ यु पिपल हेभ नट युज्ड हैन, तिमीहरूले चलाएको छैन तर काहीँ न काहीँ त टिभीतिर पनि देखेको होला नि त, एउटा यस्तो बडे टक्क लामो बडे ट्युब जस्तो हुन्छ जुन चाहिँमा चाहिँ मार्किङ्सहरु हुन्छ हैन, अनि त्यहाँ चाहिँ लिक्विडहरु केमिकलहरु के आउँछन्. So that is actually a measuring cylinder. Okay, it is an apparatus which is used in labs, okay, to measure the volume of liquids, chemicals and other solutions. And the next question says, how can you measure the volume of a small stone with its help? हैन, त्यो volume चाहिँ हामीले कसरी खोज्छ भन्दाखेरि चाहिँ step 1, what do we need to do? Filling the measuring cylinder to a certain level. Okay, filling the measuring cylinder with water to a certain level. Let's say 50 ml. हैन, अब मैले एउटा example दिएको. Let us consider we are taking a measuring cylinder and we are filling it up to 50 ml. Next thing is we have a small stone, हैन, submerge the stone into the measuring cylinder with the water. So त्यो water भएको measuring cylinder मा चाहिँ we are submerging a stone. The level of the water in the cylinder will change. It will become little bit more. Okay, so now next step is note the change of water level. Okay, let's say it has risen up to 65 ml हैन, पहिला 50 ml थियो, ढुङ्गा हालिसकेपछि चाहिँ 65 ml मा माथि चढ्यो. So अब के हुन्छ, 65 ml minus 50 ml will give you 15 ml. Okay, that indicates the stone, the volume of the stone. Okay, so त्यसले चाहिँ हामीलाई के बताउँछ भने चाहिँ the volume of the stone is actually 15 ml. So this is a diagrammatic representation. Okay, so this is a measuring cylinder, पहिला एउटा लामो बडे cylinder which has gradings हैन यहाँनिर, अन्त we have a stone out here. First we are filling the water up to 50 ml. Now we are putting stone inside it. त्यो stone हालिसकेपछि the water level has increased a bit हैन, किनभने त्यो एउटा त्यहाँ जुन चाहिँ वाटरको पहिला एउटा भोल्युम थियो त्यसमा स्टोन हालिसकेपछि त्यति भोल्युम त त्यो स्टोनले लियो नि त हैन. So water level माथि राइज भयो. So that will actually give you the volume of a stone. Okay, so this is a very crude way of doing it हैन. अब यसले exact value त दिदैन, but still we can have an approx value of the volume of the small stone. Okay, so this is by using a measuring cylinder. Next is define light year and astronomical unit. Okay, so what do we mean by light year and what do we mean by astronomical unit? So this I have discussed in the last class as well. Okay, so a light year is a distance traveled. Okay, a light year is a distance that light travels in 1 year. Okay, so light light travels with a speed of 3 into 10 to the power of 8 meters per second हैन. सो त्यत्रो स्पिड जाँदै गरेको बेलामा चाहिँ एउटा लाइट इयर भनेको चाहिँ के हुन्छ, लाइटले, okay, so the distance that light travels to complete for 1 year is known as the light year. Next, astronomical unit. An astronomical unit is the average distance between the earth and the sun. Okay, so अब earth देखिको sun सम्मको distance we can take it as 1 astronomical unit. Right, so that is defined, the distance between earth and the sun is defined as 1 astronomical unit. So the values of these are discussed in the previous class. Okay, so तिमीहरुलाई याद हुनुपर्ने हो, so that you please remember what how much does one how much does 1 light year mean in kilometers and how much does 1 astronomical unit mean in kilometers. Okay, सो यो दुईटै तिमीलाई याद हुनुपर्छ. Next is, what do you mean by dimensions of a physical quantity? Okay, so we have already understood what is physical quantity. Now we should understand what do we mean by the dimension of a physical quantity. The dimension of a physical quantity is the power to which the fundamental units must be raised to in order to represent it. Okay, so there is a physical quantity. Okay, so now to represent the physical quantity as their fundamental units. Okay, so we need to, in order to represent that, what do? We take the fundamental units and we raise it to some powers. Okay, so that will give us the dimension of it. अब यो चाहिँ कसरी गर्छ भन्दाखेरि चाहिँ there are 5 fundamental dimensions. Okay, in terms of which we the dimensions of all the physical quantities may be expressed. So there are actually 5 fundamental dimensions. Okay, so जुन चाहिँको टर्ममा चाहिँ हामीले अरू सबै चिज फिजिकल क्वान्टिटीको डाइमेन्सन्सहरूलाई एक्सप्रेस गर्न सक्छौँ. एन्ड वाट आर दोज भन्दा चाहिँ मास m. Okay, so dimension लेख्दाखेरि चाहिँ we always represent in a box bracket. यो box bracket छ नि यसमा चाहिँ हामीले represent गर्छ. So capital M with a box bracket is a dimension of mass. Length को लागि box bracket with L, time को लागि box bracket with T, temperature को लागि box bracket with theta, and charge को लागि box bracket with a capital C. Okay, so mass, length, time, temperature, and charge are the 5 fundamental dimensions. Okay, using which we define the all other dimensions of the physical quantities. अब हामीले यो बुझिहाल्यो. नेक्स्ट चाहिँ के भन्दैछ भने चाहिँ अब using this, okay, find the dimension of velocity and acceleration. So अब velocity र acceleration को हामीलाई dimension खोज्नु भन्दैछ. अब यो हामीले कसरी गर्छ? First, we know that the velocity is equal to displacement by time. Okay, so its velocity is actually similar to speed. Okay, it is only that speed is a scalar quantity and velocity is a vector quantity. Velocity किन vector भन्दाखेरि चाहिँ velocity मा चाहिँ we talk about displacement. On the speed मा चाहिँ we talk about distance. Okay, displacement is the shortest distance traveled between initial and the final position, whereas distance, it is the path length. Okay, on the displacement को कुरा गर्दाखेरि displacement itself is a vector quantity. That is why velocity is also a vector quantity. Okay, so velocity is equals to displacement by time. Displacement भनेको मतलब त्यसलाई we represented by capital S. Okay, so v is equals to s by t. On the box bracket dimension of velocity we need to find. Dimension of velocity will be equal to dimension of displacement by dimension of time. Now dimension of displacement चाहिँ के हुन्छ? Dimension चाहिँ के हुन्छ भन्नुहुन्छ? Length हो नि त. Displacement is a length. So that is why L to the power 1 लेख्छ. Length चाहिँ एउटा छ. Mass छ छैन त्यो. Time पनि छैन. त्यसले गर्दाखेरि L1 m to the power 0 t to the power 0 लेख्छ. त्यसरी नै टाइम को लागि लेख्दाखेरि टाइम के हो? सेकेन्ड्समा छ. टाइम मात्रै 1 हुन्छ. L0 m0 LMT को भेरिएसनमा लेख्छ. त्यसले गर्दाखेरि अब यो माथि जाँदाखेरि L1 minus L0 will be equal to L1. M0 minus M0 will be M0, and t to the power 0 minus 1 will be t to the power minus 1. So therefore, the dimension of velocity will be box bracket को भित्र L1 M0 t to the power minus 1. Okay, so this is understand. So there are certain examples which is given in the book. Okay, त्यो पनि तिमीहरूले राम्रोसँगले हेर्नु अझै राम्ररी बुझ्छ. Next, let us go to acceleration. Acceleration say it is the change in velocity by time. Okay, so now we have already seen what is the dimension of velocity. अब यहाँ चाहिँ के भन्छ change in velocity by time. Change in velocity भन्नुको मतलब actually it is final velocity minus the initial velocity. But anyways, final minus initial गरेर जेसुकै गरे पनि we are going to take the dimension of velocity out there. So dimension of acceleration will be equal to dimension of velocity by dimension of time. Dimension of acceleration. velocity को दिखाएको हामीले L1 m0 t to the power minus 1 divided by dimension of time L0 m0 t1 अब यसलाई माथि लाँदाखेरि चाहिँ L1 हुन्छ m0 t to the power minus 2 so the dimension of acceleration is given by L1 m0 t to the power minus 2. Alright, so these are the two things which we discussed. Yeah. And with this 11 questions, this actually totally summarizes the chapter, okay, measurement, and we'll also got a kind of a summary, okay, to and we revisited all the points as well. So I'm the Yokorizaki. There are certain fill in the blanks, true or false, and also match the following. And there are some certain objectives, one word questions and all. There तिमीहरूको bookमा छ exercise. Okay. So learn that. Okay. There are answers also provided behind. त्यो answer नहेरिकन पहिला solve गर्नु खोज्नु. जानेन भने त्यो answer हेर्दा हुन्छ. And you people will be done with the chapter. Okay. So with this, officially we have finished with the measurements. That is the first chapter. In the next class, we'll discuss much more about motion and rest, motion, and those kind of things. Okay, so next class will be the chapter 2. Okay, thank you, class.